Good evening, calculus students. So this is the video that I discussed in class today that I would be providing to help for the DeltaMath that is due this Wednesday. So let's begin with, I believe I assigned for the first section 10 problems. Now the problems vary, right? They ask for different things. So I'm going to go through maybe a couple examples to show what type of things they might ask. All right. First thing they might ask is for a critical value. Now, this one's probably the most straightforward if we remember the definition for a critical point or a critical value. My definition is simply when my derivative is equal to 0 or undefined, although I'm going to underline 0 because that's what we use most. All right, so graph of f prime of x is given to us. Right, so they gave me the graph of my derivative. I know I'm looking for when the derivative is equal to 0, so let's just look. When is my graph equal to 0? Well, this graph is equal to 0. It looks like at -8, right? Because the y value is 0. So I'm going to note here, this is a y value. All right, if my graph is equal to something, that means the y value is equal to that thing. All right, at -2, my graph is also equal to 0. And at 4, my derivative graph is equal to 0. So that's simply my final answer. My final answer that you would plug into DeltaMath would be x is equal to -8, comma, -2, comma 4. That's our final answer. Those are my critical points. Remember, critical points, they might be maximums, they might be minimums. We're going to figure that out, right? And that's sort of the next part. Next part is if they ask for a relative maximum. Well, there's sort of two steps to this, right? First step, if you remember our algebra work, right? Step one is I'm going to find my critical points again, right? Because these are potential locations for maximums and minimums. Right, so my critical points would be when my derivative, again, is equal to 0 or undefined. I'm going to just say 0 right now. Right, so my graph here is my derivative. It's equal to 0. That happens where? Well, it happens at -8, -2, and 3. Is this the same graph? Close. All right, so x equals -8, -2, and 3, right? Now, these are my critical points. I need to figure out which one is a maximum then. Step 2, right? If you remember, our previous work is our sign chart. Right, let's create a sign chart so I can see what's actually happening at each of these critical points. So my critical points are -8, -2, and 3. My sign chart is of my derivative, right? So let's label this as positive and negative. Well, to the left of -8, you'll see my derivative here. Well, it has negative y values, right? These values here, they're all negative. They're below the x-axis. They're all negative. My derivative is negative. So I'm going to label this part as negative. Next, from -8 to 2, you see these values here. From -8 to 2, my derivative values are positive. All right. Now, -2 to 3, my derivative values are negative. You can see that here. Finally, from 3 onwards, my derivative values are also negative. So it's negative, positive, negative, negative. All right, a relative maximum. When does this occur? Well, let's label my sign chart. First, my derivative goes from negative to positive. That is a minimum, right? When I go from negative to positive, the derivative, that means it's a minimum on, I'll say, f of x, right? Negative to positive derivative means it's a minimum on f of x. However, when I go from positive to negative, my derivative goes from positive to negative. That means it's a maximum on f of x, right? So my maximum occurs here, right? Because my derivative, f prime of x, goes from positive to negative, right? So my answer, final answer, is going to be x equals -2. Notice at 3, this is going to be neither, because it goes from negative to negative. We don't really have a word for that. That's a critical point, but it's neither a minimum nor is it a maximum. All right, and again, for this, you can definitely just use your eyes to sort of look. All right, final sort of question they might ask is determine on where is f decreasing. Well, for f to be decreasing, that means my derivative, f prime of x, must be what? Well, for f to be decreasing, my derivative must be negative. Right? So where is my derivative negative? Well, I would say this is a graph of my derivative. right? F prime of x. I would say my derivative is negative. It looks like from -7 to -3. So I'll write -7 to -3 combined with, I would say from 2 to 6. You can see all my values are negative here, right? All my derivative values are negative. So 2 to 6. That would be my final answer. So you can just use your eyes, really. Okay, now that answers the first question. This second question, we did not spend as much time in class about this. However, I'm hoping that we can still sort of intuitively figure this out. So to determine which statement is true regarding f prime of -7, f prime of -4, and f prime of 4. Remember, again, this is all about the derivative. What does the derivative mean? Well, derivative at -7, this means the slope. Slope of f at -7, right? And notice here, they gave us the graph of f. This is different from our previous problems, because our previous problems, they gave us the graph of f prime, right? That's different. So the graph of f, I can actually figure out what the slope is, because I'm looking at the graph of f, right? Slope of f at -7, that's the slope of f at -4. And finally, this one is the slope of f at 4. Right, so let's look at these points. So at -7, I'm going to draw down here. I'm going to look at the slope there. I'm going to look at the slope at -4, and I'm going to look at the slope at +4. All right, so let's label the slopes at these points. So I'm going to label the slope here f prime of -7. Notice my function, right? This is my graph of f. F is decreasing here. So I would label, let's just generally say, I'm going to label this slope as negative, right? So I know it's negative. All right, now let's look at -4. My derivative at -4, or my slope at -4, well, my function is increasing. It's going up now, right? You can see how it's going up. I would label this derivative as positive. Finally, the last point here, notice this is a maximum, so it would be a critical point. It also sort of flattens out at the top. That's another way to think about it. But my derivative is going to be 0, right? Because it is a maximum. That's a critical point. Critical points, by definition, the derivative is 0. You can also imagine, right, it's kind of flat up here. So my slope is 0. All right, so my slope here is negative. It's also positive here at -4. And at, sorry, this is at +4, my slope is 0. So let's order these, right? That's what they ask us to do in the answer choices. They want us to order them from least to greatest, right? So I'm going to order these least. What is the smallest one? Well, it looks like my slope, my derivative at -7 is the least because it's negative, right? So I'm going to label f prime of -7 is less than, let's see, well, 0 would come next, is less than f prime of 4. But that is less than f prime of -4 here because that slope is positive. So f prime of -4, which is the greatest because that slope is positive. All right, so I'm going to look for this answer choice. Looks like it is right here. So that would be my answer. All right, hopefully that helps clarify things. Again, this should be sort of a daily process. So yes, routinely check your email if you need assistance with DeltaMath. All right, bye everyone.